What I do want to talk about, though, is section 6.2. We want to look at factoring trinomials. What are trinomials? What are trinomials? No one knows?
We can't see because it's frozen.
I told you to make a little motion. Don't call me out like that. Trinomials are... I'll go ahead and ruin it for everyone. These are polynomials that have three terms. You should have already known this, but evidently you guys don't care. Now we want to look specifically in this section of what happens whenever that lead coefficient is equal to 1. If it's just a plain x squared at the beginning, these guys are some of the easiest things that we can do in terms of factoring. Okay. Now, what we see most often is that these trinomials, if they can be factored, come from the product of two binomials. So let's start off with this example right here. X squared plus 7x plus 10. Now, excuse me. The x squared comes from multiplying the first terms together whenever you've got the FOIL method. The 10 comes from multiplying the last terms together. The 7x, if you look at these problems where we FOILed before, the 7x, the middle term, usually came from adding the outside and the inside pieces together. That's what we were used to seeing whenever we FOILed things out. Okay. Now, if that's really the case, then I expect the first term to come from the factors that are at the beginning of the binomials. Now, what would you have multiplied to get x squared?
X times x.
You would have multiplied to get x times x. Do you all agree? And I'm claiming that my 10 is the product of the last terms. It comes from multiplying the last terms in each of these binomials. Now, how many? There's more than one way of multiplying to get 10, right? Like I could look at 10 as being 1 times 10 or being 2 times 5. Well, how do I know what I need?
2 times 5 is 2 plus 5 is 7.
Right, because you're going to have to make sure that when you add the inside and outside pieces here, you have to make sure that you come up with a 7x, right? And so maybe you do this every time. Maybe you start with this, funny little clown face, right? So there's the nose, there's the mouth, and the eyes.
It looks more like a cat.
More like a cat? Okay.
No, it looks more like, I don't know.
It looks like a hairy old man.
What? A hairy old man? Or are you talking about Harry Oldman? The guy down at the home?
That's what he's talking about.
No, it looks like a monkey.
Yeah, okay, well anyway. Now we've gotten completely off topic and no one's going to watch this video now because you guys have made it unwatchable. We'll put the 2 and the 5 here because on the inside you get positive 2x. What do you get on the outside? I'll just go ahead and tell you, positive 5x, good job. You get positive 7x altogether, do y'all agree? What do you think would have happened if I'd used 1 and 10? I wouldn't have gotten 7x, I would have gotten what? No?
11x.
I would have gotten 11x. If I'd used a 1 and 10, it would have been 1x and 10x to give me 11x. So this is your answer. In all of its creepy glory.
Can we do another one without a cat face?
I will do another one without it. No, it was a monkey face. Oh, that did remind me of MC Scat Cat, and now I'm thinking about Paul Abdul. You take 2 steps forward, I'll take 2 steps back.
Opposites attract.
Yeah, we come together because opposites attract.
That's a cool video. Nice.
And that it ain't fiction, it's a natural fact. Let's look at x squared plus 11x plus 23. Now, this is your thought process about all of this. You were trying to multiply to get that constant term at the end, the 24. But you need to make sure those numbers will add to give you 11. Okay, it's almost like a little game that we're playing here. Two numbers that multiply to give you something, but then they add to give you a different number. What numbers would you use here? Okay? 8 y 3? Sí, por supuesto. If I use 8 and 3, I get 24, right? But if I do 8 plus 3, I get 11. Is that... It's not good. What did is it still frozen? Are you frozen?
No.
So what do you think the factors would look like then? If I know what these numbers are, how do you break down the x squared?
X and X.
X times x. Now let's talk about signs, okay? You have to multiply to get a positive number, so what do you know about your signs? Is it positive, the only way to multiply and get a positive?
No, it's negative.
You can also use two negatives, right? But in this case, since I want to have a positive in the middle, I'll use two positives. All right, and I'm just going to do what?
8 and 3.
Do 8 and 3. Is that cool? How do we know this is right? Other than the fact that I'm doing it. The box? Oh, you mean FOIL? Or the box method? Or multiply? Or distribute a couple of times? Yeah, that one. Word. X times x is x squared. 8 times 3 is 24. Inside you get plus 8x. Outside you get plus 3x for your grand total of 11x. Right? Because you're adding those like terms together. Really? Really? You went there? See, I always thought that'd be like one of the, like a great name for, you know, a Vietnamese restaurant. I'm like, are you sure we should eat there? For sure. Yes, it's perfect. But you got to watch out if they start adding some kind of royalty title here at the end, like, you know, king. It just does not sound right. So let's do another example here. X squared minus 15x plus 50. Now, is there a common factor for all of these terms here? 5 goes into everybody?
No. For the 50.
I don't care about just a couple. I'm talking about everybody.
1.
1 goes into everybody, right? Do I need to write that? No, because it doesn't actually help me here. So I expect this guy to factor as 2 binomial factors. This is what I'm expecting when I have a trinomial. Don't instantly jump here because you want to look for a common factor first. Now, how do you think you're going to break down the first term? As x times x? What signs do you think you'll use for the constant term? A negative? So like a negative and a positive? Both of them being negative. Do you all agree?
Yes.
Because what's negative times negative?
Positive.
Positive. However, when I do the adding on the inside and on the outside, I'll have 2 negatives. And if you add 2 negatives, what do you get?
Negative.
You get an even bigger negative, right? So think about the factors you have for 50.
10 times 5.
Say again?
10 times 5.
10 times 5. If you aren't sure, write down all of the factors that we have. 1 times 50, 2 times 25, 5 times 10. Those are all of the factors we have. Now, since they need to combine to give me 15, we know that the combination is going to be 5 and 10. Does that multiply to give me a positive 50 when I multiply these numbers?
Yes.
Yes. when you check your work on the inside, you get a negative 5x. What's on the outside? Negative 10x, so altogether is a negative 15x. So see that everything checks out here. Now you know that some of these numbers can get large and they can just be very difficult to manage. What you can do is you can look at them in terms of their factors. So if I do a factor tree with 50, we know that this guy breaks down to be 2 times 25, and I can break down the 25 to be 5 times 5. Now the reason I do that is so that you can see the prime factorization of 50. So when you're trying to make a list of factors like I have here, you don't have to worry about what numbers go into 50 because they're all listed out here for you. So I did 1 in the number, I did 2 and 25. You see here's 2 and 25 is right here. Does 3 go into 50? Other than the fact that you just intuitively know that 3 doesn't go into 50, look here at the factors. You don't see a factor of 3 anywhere here, do you? Okay, what about the number 4? Now, to see a 4, you'd have to see what it is based on its prime factors. What's 4 made up of? 2 times 2. Do I have 2 times 2? So that doesn't go in here. You see we have 5, and what do the other factors make up? Here's 5 right here. The other factors are 2 times 5, which is 10. Right, it's supposed to because I'm using all those factors. What about 6? Does 6 go into 50? No, to see 6 you'd have to see a 2 and a 3, but didn't we already say that 3 doesn't go into 50? Didn't we say that? So if 3 doesn't go into 50, no other multiple of 3 will go into 50. So forget about 6 or 9 or 12 or any of those guys, forget it. What about 7? Does 7 go in here? 7's a prime number, I don't see it listed here, no good. 8? Well, isn't 8 a multiple of 4? We said the 4 doesn't go into 50, so no other multiple of 4 will. So forget 8 or 12 or 16, forget those guys. We already said forget 9, and then all of a sudden we're at 10. 10 has already been spoken for, so there's no need for me to go any further. Because all the other numbers are just going to be going up the line here. So this is a way for you to make sure that you have every possible factor listed for your number.